and Happy New Year! I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. What if doctors could detect cancer, even the slightest amount, earlier and monitor its progression much less invasively than with existing approaches in the lab? It's possible thanks to a new Raman imaging system. A team from Michigan State University has developed the system that's compact and sensitive enough to differentiate cancerous tumors from normal tissue. Using surface-enhanced Raman scattering nanoparticles, which attach to tumor markers, it can detect even the weakest signals. More specifically, upon reading signals, the small system automatically highlights areas that are more likely to contain tumor tissue. It distinguishes between cancerous and healthy cells as it detects Raman signals. These signals, which the team says are 4 times weaker than what can be detected via conventional systems, were achieved using a swept source laser and an ultra-sensitive superconducting nanowire single-photon detector. The team says the new system's compact size makes it a promising rapid screening tool that could accelerate cancer diagnosis and treatment, ultimately resulting in more positive outcomes for patients. Changes are on the horizon at Germany-based integrated photonics technology developer Jenoptik, with the recently announced resignation of President and CEO Dr. Stefan Traeger, which becomes effective next month. Jenoptik representatives say that under Dr. Traeger's leadership, which began in 2017, the company has developed into a profitably growing and increasingly focused photonics group. While no reason has been given for the departure, Jenoptik representatives say it's a mutual agreement. The company is now searching for a successor. Jenoptik has also announced the appointment of Daniela Matthews as chair of the company's supervisory board. Matthews, a lawyer and management consultant, has served on the board since 2023 and says she aims to help keep Jenoptik on its path of profitable growth. Elsewhere, Quantum Computing Incorporated, a quantum optics and integrated photonics technology company based in New Jersey, has named Dr. Yuping Wang its new CEO. Company officials say the move will bolster a continued focus on growth and scaling quantum photonics systems for industrial and commercial use. A phenomenon commonly referred to as an optical bomb could pave the way for practical quantum technologies. Called superfluorescence, this quantum phenomenon involves multiple excited emitters that can spontaneously synchronize their phases and emit bursts of coherent light. But not all materials can handle such actions. Looking into why that is, and whether collective quantum phenomena like superfluorescence can exist in disordered materials and at high temperatures, an international team led by researchers at École Polytechnique in France has made an important discovery. Crystalline semiconductors, specifically lead halide perovskites, which have a unique lattice structure and optoelectronic properties, are better at superfluorescence. The team calls this perovskite material a promising platform for exploring quantum effects. Their work involves time-resolved photoluminescence measurements, allowing them to track the real-time evolution of a quantum phase transition from incoherent exciton polarons to a collectively coherent state. The team ultimately found stabilization of macroscopic quantum coherence within solids is possible at elevated temperatures, which they say addresses a long-standing challenge for condensed matter physics. While the team's study remains fundamental, they're now working to develop experimental methods in ultra-fast quantum optics. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.